Welcome all of you to the today's lecture session on sign test. Sign test is a simple non-parametric technique which is based on the science, and in this session we will discuss about uh, what is sign test and how the sign test can be applied to the small sample as well as large sample. So if more than 25, if the sample size is more than 25, we consider it as a large sample, and how we'll calculate a sign test for the large sample, and also if it is less than 20 equal to 25, so how you are going to calculate the sign test for the small sample. Welcome to the lecture session on sign test. The sign test was first introduced by Arthur Boutnot, which is a Scottish physician in 1710, and the sign test is a non-parametric test that can be applied in a variety of situations, such as when the data have two possible outcomes which can be used to test whether these two outcomes have equal probability. And it is also a special case of the minimal test. It can be also used in paired data analysis. It can be used when the variable of interest is ordinal interval ratio and one wants to test whether the median of this variable is some given value. The sign test can be used to perform the following type of test, like use the sign test to test a population median, use the paired test, paired sample sign test to test the difference between two population median, it is dependent samples. Sign test for a population median, a non-parametric test that can be used to test a population median against a hypothesized value k, where we take the null hypothesis, median is equal to k, the alternative hypothesis, median not k, okay, which is a case of two-tail. Median null hypothesis less than equal to k, where alternative hypothesis median greater than k, which can be a case of right tail. Similarly, we can go for left tail, and here each entry is compared with a hypothesized median. If the entry is below the median, a minus sign is assigned. If the value or the entry is above the median, a plus sign is assigned, and if the entry is equal to median, the 0 is being assigned. The one sample sign test simply computes a significant test of hypothesized median value for a single data set, and again it is a non-parametric hypothesis test used to determine whether statistically significant difference exists between the median of a non-normally distributed continuous data and a standard. The assumption of the one sample sign test, data is non-normally distributed, a random sample of independent measurements for a population with unknown median, the variable of interest is continuous, and one sample test handles non-symmetric dataset, that means it is being skewed either to the left or to the right. And the procedure what we follow, state the claim of the test and determine the null hypothesis and alternative. You determine the level of significance. You assign the positive and negative sign to the sample data and determine the sample size n, which is equal to sum of positive and negative sign. You find the critical value. If n is less than equal to 25, use x, where x is the smaller number of positive and negative sign. For larger sample size, if n is greater than 25. Make a decision. Null hypothesis will be rejected if the test statistics is less than or equal to the critical value. Then interpret the decision in the context of the original claim. This is the test statistics for sign test for large sample. When n is greater than 25, the following statistics is used, where n is total number of plus sign and minus sign. So z is equal to x plus 0.5 minus n by 2 upon root over of n by 2, where if x is less than n by 2. If x is greater than n by 2, then we go for the correction, that is minus 0.5, and where x is what? The number of plus sign. And when n is greater than 25, n is equal to sum of x plus sign and minus sign, and this is the way how we calculate for the large sample. Now let's look into this problem. to test the claim that the median age of the patient admitted in the cardiology department of hospital is at least 42 years. The results from a random sample of 32 patients is given, and these are the data what we have collected. Use the sign test at the 5% level of significance of the to test the claim. So here the null hypothesis, median greater than or equal to 42, median less than 42, so less than, so it is a left tail, alpha is equal to 0.05. Replace each value greater than median, that is 42, by plus sign, and those with less than by minus sign. If equal, median value replace with 0. You see 56, 42 is less, 56 is greater than 42, so plus sign. 62 is greater than 42, so plus sign. You see 38 is less than 42, so minus sign. You see 42 is equal to 42, so 0 is being assigned. So one value is 0, you drop out that one. So there are total plus sign 14, total minus sign 16. So here n is equal to 32 minus 1 is equal to 31, because we discard the 0. One x represents the number of plus sign. Now we put the value. So since n is greater than large, we use a normal test, and if n is large, we use normal approximation to the binomial distribution. So where x is equal to 14, n is equal to 31, we put the value, then we get z is equal to 14 plus 0.5 minus 31 by 2 by 31 root over by 2, so we get minus 0.36. So the critical value of z for left tail at 5% level of significance is minus 1.645. The calculated value falls in the acceptance region, so we accept the null hypothesis and conclude that the median age of the patient admitted in the hospital in the cardiology department is at least 42 years old. We look into this, where we have the rejection region. We have the rejection region, that is minus 1.645 minus 1.645, and here the z is equal to 0, and here we have minus 0.36. So this is the acceptance region, and this is the rejection region. So as the value fall in the the calculated value fall in the acceptance region, so we accept the null hypothesis. So now we'll discuss about sign test for small sample, that is n less than or equal to 25. So the manager of e-commerce company claimed that the median number of customer order per day is 63 during the lockdown period. In the same company, the assistant manager from the same company claimed that it is more than 63. So he started collecting the number of order per day from 10 random day and test the claim of the manager at 0.05 significance level, and this is the data what they have got. Now solution, number of order median is equal to 63, null hypothesis. Alternative hypothesis, number of order median greater than 63. So now you assign minus if less than 63 and plus sign if more than 63. If equal, place 0. So this is the way how we got the plus and minus. So now the total number of value of plus is 8, the total number of minus value is 2. So n is equal to the number of plus sign and number of minus sign, that is 10. X is calculated as smaller the number of plus sign and number of minus sign. So minimum of 8 and 2. So that is 2. The test statistics is minimum of 8, 2, that is 2. The critical value of x for n is equal to 10 at level of significance 0.05 for right tail is 1. So this 1 value we got it from the sign test table. So the critical region is x less than or equal to 1. Since the test statistics x is equal to 2 as per calculation lies outside the rejection region, so we accept the null hypothesis and conclude the median number of order per day is 63. So here hints is about the note, if x is less than or equal to critical value, we reject the null hypothesis. And this is the table from where we got the sign test table. N is equal to 10, then for right tail alpha 0.05, we got the value as what? 1. And this is the sign test table. And this is are the references what you can follow.